Dear students, welcome to Pen and Paper Chemistry on YouTube. We are continuing with our topic of diazonium salts, and I hope and I'm very sure that you must have at least practiced the preparation of these diazonium salts from our earlier video where we discussed what are diazonium salts. Now, may not be having this as a separate topic in your syllabi, but as I mentioned earlier, there are a lot of reactions which are based upon diazotization and diazonium salts. So that is why it makes better sense to do it as a separate compound. So let's get started. A quick revision. How do we prepare them? Aniline reacted with nitrous acid. Now, where is the nitrous acid in this? Oh, I don't see it. Oh, okay. We are going to get it by double decomposition in the reaction mixture itself, and we call it as preparing it in situ, right? In the reaction mixture itself. Now, this gives us the benzene diazonium salt, sodium chloride and water. Now, where all can we use our diazonium salts? Broadly classified into two categories, diazonium salts show electrophilic aromatic substitution. There are two parts which can behave as an electrophile. So if you notice on the left hand side, I have put the phenyl group as an electrophile, and on the right hand side I have put the diazo group, the diazo ion, as the electrophile. How does it happen? So you can have a quick overview of this chart so that you can draw this chart yourself as well. It will come in very handy to give you a bird's eye view of all the different preparations that can be done using the diazonium salts. First category of reactions, the electrophilic aromatic substitutions. How do they happen? We know that nitrogen tries to break away from this, leaving a phenyl ion and nitrogen gas. Now this phenyl ion, C6H5 positive means it is going to behave as an electron loving species, hence can be easily attracted by a nucleophile, giving us the product. So let us use this ability of the diazonium compound to get rid of the nitrogen to prepare a large number of compounds. The first one that we've got here is benzene. How do we prepare it? By simple reduction of the diazonium salt using hypophosphorus acid and water. That means in an aqueous solution. The second is we are going to prepare phenol. How do we do that? By hydrolyzing with an acid. So this gives us phenol, nitrogen and HCl. Third, replacement by the SH group. Now when you replace it by the SH group, you see we are again concentrating on our nucleophilic substitution. Remember, we did similar reactions with alkyl halides as well. So we had Rx plus the nucleophile, so RNU, because our alkyl halides were undergoing nucleophilic substitution reactions very easily. So the same fundamental applies for the reactions over here. Next, iodobenzene, C6H5I. Remember, we did in halogen derivatives of benzene that it was very difficult to prepare the chlorobenzene, the bromobenzene, the iodobenzene, and you had to use extreme conditions. So that is why we found this quick way out. So the aniline converted into benzene diazonium chloride, you convert it into the halo derivative, and then what do you do to get rid of the NH2 group? Yes, you reduce it. Okay, don't worry. We will write reactions of this, and then whatever doubts are will become clearer. I've classified the Sandmeyer reactions into one category. Sandmeyer reactions are you're taking the copper salt of the halogen and of course the hydrogen halide heated. So you have the benzene diazonium chloride CuCl plus HCl in the presence of heat. So what's our nucleophile over here? Simple, Cl. You want to prepare the bromo derivative. So diazonium salt plus CuBr, HBr gives you the bromo derivative. A little modification of the Sandmeyer reaction is introducing the CN group. Now, if you introduce the CN group, a lot of our preparations become very easy. Why? Because this CN group can be converted into, you remember, we converted it into an amide. We converted it into the amine. We converted it into the acid group. So this way a large number of compounds can be prepared once the CN group gets admission into the aromatic compound. Isn't it fun? Catamaran reaction is slight modification from the Sandmeyer. You observe the two reactions. See them very, very carefully. What difference do you notice? Yes, instead of taking the copper salt, we are taking copper and heating it with the hydrogen halide. So if I'm heating it with HBr, I get the bromo derivative. I heat it with HCl, I get the chloro derivative. I heat it with KCN, I get the cyano derivative. Of course, this is again a modification of or adaptation of the Catamaran reaction. Once we start writing the reactions, I'm telling you, you will just sail through this topic very, very easily. These are nothing new. You have done them and you will be covering them in your aromatic compounds. Another interesting compound that we prepare. Now you remember we said that the fluorobenzenes are a little difficult to prepare because they are explosive as well, so we don't meddle with them. The reactants. So what we do is we found a wire route. We reacted the diazonium salts with fluoroboric acid to give us the compound diazonium fluoroborate. Now this can be either treated with aqueous NaNO2 sodium nitrite, where my nitrite becomes the nucleophile and I have the compound nitrobenzene. Alternately, we can heat it to dryness. Now you must be wondering that in my previous video I said that these were very unstable, diazonium salts were very unstable and explosive in nature. Interestingly, the fluoroborate derivatives, they are good. They don't explode, they are cool, they are not so short-tempered. So when you heat them to dryness, you get the fluorobenzene, and this reaction is given a special name, the Bals-Schiemann reaction. Have you noted these down, or is it becoming too much of information? Just note down the chart. If you followed the earlier videos, you will know that this is going to actually make organic chemistry very, very easy. So just note down this chart, draw it yourself, and try and put colors in order to remember and recall. Oh, you notice I've got something over here. I've got the orange and the yellow colors. Oh, this is pertaining to the coupling reactions. What are coupling reactions? So you notice over here, my C6H5N2 positive is going to behave as an electrophile. So when it combines with C6H5N here, it combines with another, what group is this? An aromatic compound. So it couples with it. They form the two rings joined together and we have the products here. So for example, we form the orange dye parahydroxyazobenzene. I am sure you would have done this reaction under phenols, or you will do it under phenols. So the diazonium salt, now here it is this part which is going to act as the electrophile N positive. So with the result reacts with phenol under slightly alkaline conditions to give us para-hydroxyazobenzene. Because it's got an orange color, I thought it would be nice to give it an orange color just for easy recall. On the other hand, when you reacted with aniline under slightly acidic conditions, you get a yellow colored dye which is known as para-aminoazobenzene. Para-amino because relative to the diazo group, I have ortho, meta, and the para position. So para-aminoazobenzene giving us a yellow dye. So you see the difference with phenol, the diazonium salts are giving us an orange color, whereas with aniline, they are giving us a yellow color. So where can you use these two reactions? Yes, of course, you can use them as tests for phenol and aniline, and that is one of the tests that you are going to do in the laboratory. And I pray that you get a chance to do the practicals and observe things for yourself, because it is all about learning by doing. And that's what we are going to do in the next video. In this video, I've just given you a flow chart. In the next video, I'm going to take up the reactions, or these reactions step by step. We are going to list down the reactions. But before that, why don't you take up this flow chart and try to look at it at least 3 meals in a day, just for 2 days. Just read these flow charts, observe them, and that's it. Your organic chemistry will become very, very easy and very interesting. See you in the next video. Take care till then.